Okay, so we just finished with this plot. This was for the maximum pH, and so now we're going to start on part 2 of the algae data mining problem. So we showed how to uh, do this kind of, we first showed how to summarize uh, the different variables, and we also showed how to visualize one particular variable in terms of its histogram and how close to the normal it is. Now we're going to do a different variable and show some other ways for visualizing the data. So let's go back and check what were the other variables involved here. We had all of these variables, as we said before. This time we're going to look at this one, OPO4. So we're again going to look at how this variable is distributed. We're going to use a different graph or different picture. So let's try this, and that gives us this picture here. And this is called a box plot. And basically this thick line here is the median for the data, and this is called the lower quartile, this value here. So the median is about maybe 50, a little less than 50, and this is maybe around 20, and this is maybe around almost 100. Okay, so this is called the third quartile, and this is the first quartile, this is the median. This gives us a kind of indication of where most of the data lays. It lays in around here, and there's a kind of spread of this much around there. And then there's some data points that are way out here. That's what this is saying. So there's some that are, we would probably consider a lot of these or all of these kind of outliers. So we use the box plot, and the data we're looking at, the variable is here, and we just gave the box plot the y label a name, or the y-axis a name rather, like this. We can also use the same function we used before, the rug function, and with a jitter again. And now we're going to use it on the vertical axis, I believe. So you can see that most of the data is around here. There is data up here, data up here. It's spread out up here as well. And here we're going to put in a line, and we're going to make it a horizontal line located at the mean of this data set after we've removed all the NA data, the not available data. And after we do that, you can see there's a horizontal line here at the mean. So this shows that the median is here, but the mean is higher. And that's because these values affect the mean. That is, outliers tend to pull the mean in the direction of the outliers, but the median is not really, doesn't really work like that. It's not really sensitive to those outliers. Let's quickly check to see a little bit about this AB line function. So this is the AB line help page, and we can see that it takes a bunch of different arguments, and I'm looking for the LTY one, but it's not really here, but it is down here. It says sorry, it's here. It says LTY here. It says check this one. Remember, we just used this one in a previous video. And it turns out that LTY is just the line type. You can have blank, solid line, dashed line. So we used LTY equal to 1. I'm sorry, LTY equals 2? No, sorry. Yeah, LTY equals 2. What would have happened if we used LTY equals 1? Let's try that. same. Anyway, the parameters we could also set them, I guess, like this. Here, 1 is solid, 2 is dashed. Well, okay. Sometimes I guess it will show up as a, maybe I didn't refresh the screen or something, but now it's a dashed line. So again, looking at this plot, we can see that most of the values are down here and down here, but there are quite a number of values up higher, so there's a kind of skew in the data. We say there's a positive skew since it's higher values. So this means that in most of the water samples, the value of this variable is low, but there are several observations with high values, and even with extremely high values. So we might want to look at these high values. This is a good thing to do. So we can try it graphically first. So what we're going to do is first we're going to look at a different variable. So let's do that. So we're going to look at NH4. And this is a graph of NH4 and the values of it. And now in this graph we're going to also put the mean line, horizontal line. So you can see the mean is here. And now we're going to plot another line, which is going to be a horizontal line, the mean plus the standard deviation of this data. And we're going to specify the type of line as well. And let's see this one. So now we can see the standard deviation, one standard deviation here in this direction. And then we're going to plot yet another line, and this one's going to be the median of the data. And that's, I guess, this dotted one down here. And now we're going to run one more function called identify, and that will just enable you now to click on a dot and see information about it. So this is the 20th piece of data, the 35th piece of data, the 153rd piece of data. So we can see that the 153rd piece of data is very much an outlier. So let's make note of that. And now to get out of this this mode on the graph, you just right-click on the graph. And these are the ones that we clicked on. So the 153rd is very much of an outlier, at least with respect to this variable. Okay, now let's run this plot, or this graph, and that looks like, I'm sorry, that's the same graph. And then we run this, and now what this is going to do is, now we did the same thing as before, except now remember that this actually output these values, and so we're going to just store those values in here. So let's click on a few of the possible outliers. And now it's stored in that variable. And now what we're doing is we're taking, so for example, we might have 20, 35, and 153 and clicked lines. And so that means we're extracting those rows when we do this from the algae data set and all of the columns. So we can therefore examine those rows. So we have row 20, 35, 88, and 153. And so we can look at these fairly easily now. So remember, this is a kind of indexing, and we've talked about doing that, or subsetting of a data frame, using a kind of logical expression as a row selector. Now, depending on the values that you clicked, you might have gotten some not available data. So in order to avoid that, you can do it this way. You can run this. So here again we're working on the algae, but we're saying if it's not available and it's greater than 19,000, then select it. Let's try that. Something's wrong with that. Let's try it again, but without the dot there. And so actually it's only row 153 that is the one that we're interested in. So just to review this a little bit, this symbol here is a not operator, so it says not this. So we're doing a logical expression here. So this might be true or false, and this might be true or false. So this is an AND statement, an AND connector. So we have true and true, then we'll print it. But otherwise, if either one of these is not true, we won't print it. So in particular, if this is not true, then we won't print it, and that means that this is what, if it's an NA, then so if that's not true, then we'll print it. So that's what we want. You can think about that. Now if we run these two again, now we're looking at the other variable, OP04, and we're using the identify as well. And let's click on a few of these. This is just a box plot. Okay, you can't do that. Let's try this one. And that one. Okay, so we can do that. I was checking to see whether any of these outliers were also outliers for the in terms of the other variable, but it doesn't seem to be quite like that. So anyway, we can store that, and then we can stop. And we could still run this. And in this case, we have these records. So this is a way to inspect the outliers. And if you were making a report, you'd want to, or write a paper, you'd want to mention these outliers for any of the particular variables. Okay, next we're going to use another set of tools to do the same thing, to look at the distributions of variables. We're going to look at different variables this time, but we suppose in this case that we want to look for not just distributions, but how they're related to other variables. In that case, we're going to do something a little bit different. We'll do that in the next video.